Okay, good morning, everyone. Here is Hong Wang from BSMI, and I would like to present my presentation study of how to use classical operation in digital bit to simulate for quantum bits in RSA encryption systems. As we know, there are 4 parts for the classical bits and quantum bits. We focus on the quantum bits measurement. The second part with basic operations for bit exchange and quantum bit strain that would be eliminate the quantum informations. Third part, so we can increasing the complexity of public key with quantum piece, use the random number generator to simulate the quantum piece. And the fourth part, we use the flow of the public key and modify with the quantum piece. The first part, we consider about the quantum bits measurement. Here is the classical bits and the quantum bits. Classical bits 0 and 1. Quantum is a random sphere number here with alpha and beta angles, and we measure these 2 possible outcomes for the quantum piece, usually 0 and 1, like a binary digit, but with kind of randomness. This is like a result of Schrödinger's cat. The objects are state of superpositions. The cats both can be alive or dead, depend on like a random process of radiation process on or off. But we consider, just Albert Einstein said that God does not play dice with the universe. So we consider the systems of these basic operations for quantum measurement is kind of randomness, but we can stimulate by systematically. Second, we consider the bit exchange. First, we use the NOT gate that will change reverse 2 different positions, change the gate informations. And we have a linear map of the P gate, which will be eliminate the noise. No matter here is 0 or 1, the final will be 0, and the data will be disabled. Third part is we use the increasing the public key in quantum bits, which one is, for example, we used a large of public key with 2 power of p minus 1 plus 2 power of q minus 1 with r quantum bits. So the combination of this result will be p plus q plus r factor with these factors, but the randomness r factor will be put into 2 power of r. For increasing of complexity of public key with qubits, we choose the first large one in M. First one is M825899933, and the second one is 77232917. We use the first 2 and consider the third part with M742072881. In here, we consider the large term prime number and the second one number compare with the public key. And we use the big number of 121 quantum piece in IBM's quantum computers. We can get combination of this public key has different ways. First, in the same length, we choose the first large 1 prime number and the third large prime number, and we can get the p is the same, but q will change. sorry. And the public key will change to the digit system will change to with randomness increasing for this one from 100 quantum bits 1121 change to 3 millions over 3 millions quantum bits. So the system capacity just 1121, but how do we use to increase it to the 3 millions? We all use the random numbers to stimulate 0 and 1, and we eliminate p number, let the evaluate quantum based random number generation put into the RAM and replace into the oldest or originals n plus to into the systems. So we can complicate our public key n into the n plus n stars to the new one, and we get the new system informations. For public key, we can get the public key and the private key. If we can get the power of p minus 1, and then get the 2 minus power of q minus 1 equal. So we can use this process directly get the informations. So in the original one, here is the complicate public key to these systems. And when we use this randomness, the quantum key put in our simulation random number put in here, and we can get the randomness of n stars to random numbers. This is different. The situation in outside systems, you cannot know that this bytes is be replaced or is quantum random generated. So you always need to how to back to our revised schedules and the places and the drain systems to into the systems. The same way we can get into our systems back to our simulation, the same. We just put back to reverse our n to into the n star the same way. So this is the good method and efficiency to increase our quantum capacities, to increase the random number, and increase our safety. Instead of we can get our n public key n easy by Shor algorithms solve the problems. So let's our studies use the random number generator instead of quantum keys to simulate and to randomize our n-star public key to get the more complicated system to secure our information to our data in our mode the same way. That's our study from the beginning of this research and get for this result in publish our statements. That's our presentations. If you have any questions, please contact us by email and I will reply you as soon as possible. Thank you very much. Thank you, sir.